In this lecture, we're going to look at interface classes, and then specifically the comparable and the comparator interface classes. So we'll get started by just looking at a definition of an interface. So an interface is just a protocol between two separate entities that allow them to interact. So we can have an interface between a car and a human, which would consist of having a steering wheel, accelerator, the brake, knobs on the radio, the ignition, etc. You can have an interface between a TV and a human, which would consist of a remote control and all the buttons associated with that. And then we can even have an interface between two humans that speak a particular language. For example, English can be an interface between two humans. So it's just a way for two separate entities to interact with one another. We'll look at an example here, and then we'll look at specifically how an interface is implemented in Java. So here we have a definition of a interface class, public interface drive. Now we're going to notice something here. In this particular class, all we have is the method declarations. There are no method bodies associated with this. So this is very similar to declaring an abstract method within an abstract class. In fact, all these methods are abstract methods, but since every method declared within an interface class cannot be implemented, they are by default abstract, and so you don't have to add the word abstract here. So this interface class has a steer, accelerate, and then decelerate. Now how we use an interface class is we say public class, whatever class our name is here, and then the keyword here is implements. We use the keyword implements to implement an interface. We implement the drive class. Similar to our abstract classes, if we have an abstract method, then we are forced to implement that abstract method if we extend an abstract class. If we implement an interface, then any class that implements that interface must implement those methods. So we must have a completed steer method, an accelerate method, and a decelerate method. So if we look now specifically at the definition, a Java interface is just a class is a set of unimplemented methods that specify the signature of the method. So they're just some abstract methods. You cannot create an instance of an interface class, just like you cannot create an instance of an abstract class. The motivation behind declaring and using interface classes is that you want to create a class that declares methods that you want other classes to implement to have. So again, it's like abstract classes or building a class hierarchy. We're trying to capture similar behavior between our classes. One key thing to note here about interfaces is they should not change over time. So once you've made an interface class and have added your method declarations to that, if you go in and then later on add a new method declaration to there, what's going to happen is every class that has implemented that interface is now going to be forced to add that method. So it can really cause some maintenance issues if you come in and start adding new methods to your interface classes. Just comparing interfaces versus abstract classes. When we look at interface classes, these are classes that are going to implement some type of behavior. So they're able classes or sort of can-do classes. Java allows you to actually implement multiple interface classes. If I come back here on this particular slide, let's say I had another interface class I want to implement, I can say implements drive, comma, and then just put the name of the other interface that I'd like to implement. An abstract class, again, is a class that we cannot instantiate, but this falls along the lines of an ISA. For example, a blowfish is a fish, a shark is a fish. Whereas an interface, if we're going to capture behavior there, we're going to try to capture what a class that's going to implement that interface is capable of doing. For example, we might implement like fish behavior, and so we might have a swim, breathe, etc. And so that may be captured in an interface class that we may use with a fish hierarchy. Another difference between an abstract class and interface class is an abstract can only be extended once. You can only extend one abstract class, and an abstract class can contain data members and implemented methods and abstract methods. Whereas in an interface class, the only type of methods that you can have in there are those abstract methods, which means they're all unimplemented, and you cannot have any data members within an interface class. So now I want to set a backdrop to set the stage for two type of interface classes that we'll be looking at here, the comparable and the comparator interface. For this backdrop, remember that when we're developing software, a lot of times we're going to want to store a collection of data. And so this is a group of data that's related by being the same type. And so as we've learned through polymorphism, that same type can be a base type within our class hierarchy. There are other types of data structures out there. We've been using the array list, but there's sets, there's maps, there's trees, which are a little bit beyond the scope of this class, but I want you to know that there are several different types of collections out there. We may store a list of shapes, we might store a list of students. When we have this data structure, usually then what we want to do is begin to operate on that. There's usually a common set of behavior that we want to perform on our collections. For example, we may need to reverse our collection. We may need to find the minimum value or a maximum value. We need to sort that collection. So Java has provided a set of methods that we can be used on any of its collection classes, for example, the collection class array list. And these methods are found in the Java util collections. And these are a set of static methods that are part of this class. That means that you can call them directly without instantiating a collections object. And as I said before, these are some example methods there that we can use. So what's our motivation in using these type of collection classes and using methods that have already been developed is one, is greater productivity because we don't have to go reinvent the wheel. So if I need to sort my data, I don't have to go out and write a sort method, or if I need to find the min or the max, I don't have to go write those particular methods. I can use classes and methods provided by the Java API to expedite my development. And what that also means then, because these have been developed through the Java API by other developers, they've been thoroughly tested, that means I'm most likely going to have fewer bugs in my program. So now I want to move on to sort of a very specific example here. One of the things that we commonly want to do is look at sorting our collection of data. Looking at here sorting arrays and array lists, it's possible to sort both of these type of data structures with methods provided by Java. We've talked about the collections class, so I can go collections.sort and then pass in my array list, and that's going to sort that if it is a well-defined type. For example, it contains doubles or strings. If I have an actual array instead of an array list, and we'll talk about arrays later in a class, I can call arrays.sort and sort my array. Array is very similar to an array list, and we'll get into the differences later on in this course. I have a collection of data. Here I've actually declared a string array, fruit, and it has orange, apple, banana in it. I've declared that. I can say arrays.sort. It's going to sort my fruit array, and then I can go through and print that out in sorted order. If that fruit variable was an array list, then what I could come here is just call collections.sort, and it would sort that. So we can take advantage of some of these utility methods provided in the arrays class or the collections class to help us as we operate on our data within our program. Calling collections.sort or arrays.sort works very well if you have a well-defined type using one of the types provided by Java. For example, it works well on integers and strings because we know what it means for one integer to be less than another, or for one string to be less than another. If you have a array list of integers or array list of strings, you can just call collections.sort on those, and it's going to sort those for you because everybody knows what that means, and Java knows what that means for one integer to be less than or greater than another one. But what happens now if we move on and we have a collection of student objects or a collection of car objects? So as an example here, let's say I have given an array list of student objects called CS6312 students, which stores the first name, last name, etc., grade, height of all the students in a class. If I call collections.sort and I say CS6312 students, which is an array list of students in my class, it's going to say, I don't know what it means to actually sort those because I don't know how to compare one student object to another. Do I compare them based on first name, last name, their grade, their height? So it's going to generate an exception. So if we have a collection of a user-defined type, does that mean that we're going to have to write our own sort? The answer is no. So this here is where the comparable and the comparator interface allow us to define an ordering between user-defined types. If we implement this interface, what it forces us to do is to implement this public int compare to. The compare to method, what it does, it returns 0 if the two objects that you're comparing are considered to be equal. It returns a positive integer if this object is greater than the parameter object, in other words, this O. And then it's going to return a negative integer if this object is considered to be less than the parameter object. So we'll look at an example here to help clarify this. So let's say I want to compare two student objects based on the student's grade. So I've got my class here. Class student implements the comparable interface. Now, one of the things, it is written to be a generic type. So what we want to do then is to actually use a template to templatize that so we know what actually type of objects that we're going to be using in the compare to. So this is where I will come in and I'll put my templatized type in here. And so we're working with students. What this forces me to do is come in here and implement the compare to method. Now notice here, it's going to come in here, it's going to say student, and then we're going to have to give this parameter a name. When you do it in Java, it's going to get probably a default variable name of O. I like to come in and give it a little bit more meaningful name. So then I have to come in and define what it means to compare to this object and the other student object. So it automatically, when it gets called, you don't call this necessarily directly, but if you call the sort method or the min or the max, it's going to go through and do that comparison for you, comparing two objects. Which one will be referred to as this object, the other one will be passed into this parameter. So I'm going to say if this is get grade is less than the other student's grade, then I want to say that this object should occur before or is less than. So I want to return a -1 or any sort of negative value. If this object's grade is greater than the other student, I want it to occur after that, saying that it's greater than, so I want to return a value greater than 1. For example, I can return 1. In this instance, if it's not less than or greater than, it means that the two grades are equal, so I want to say these two objects are now considered equal, so that means I'm going to return a 0. Now, if I want to look at this here another way, I can implement that same comparable interface, the compare to method, a little bit simpler. Instead of coming in there and having the if else, what I can do is just simplify that by saying return this.getGrade minus other student.getGrade. What this does, let's say the grade here is 72. 72 minus, let's just say this grade is 80. 72 minus 80 is going to return a -8. So a -8 means that this object is considered to be less than the other object. If I have, for example, that this grade is 90, this one is 85, it's going to return 5, which is a positive value, which means this is going to be that this object is considered greater. And if they both have the same grade, 80 minus 80 here, well then it returns 0, meaning that those two objects are considered equal. That's great. We are able to compare based on whatever we implement in that comparable interface. For in this particular example, we've compared the students based on their grade. But let's say I want to compare the students based on some other criteria. Maybe I want to compare them on their height or their age or their name. Since I've implemented the comparable interface, I can only compare based on that one attribute there. If I wanted to compare something else, I'd have to go back in and rewrite my code. And we don't want to be able to do that. And what if I want to be able to sort on different criteria? So then Java allows the capability to implement a comparator interface. It's very similar to the comparable interface. The method that you're going to have to implement is called the compare method, and it takes two parameters, which are going to be the two objects that you're going to be comparing. So to create a comparator class, in this example, we're going to compare the height of two students, and instead of this being associated with the actual student class, what you often do when you're implementing a comparator is you're going to make a whole new class and give it a name which is indicative of what criteria you're going to be comparing on. So here I'm comparing the height, so I'm going to call this a height comparator. This implements then the comparator, Again, it's a templatized type. We're going to be working a student object, so I'll indicate that here. That forces me then to implement the compare method. I've come in here, we've got our student objects. I've renamed them to be student1, student2. In Java, when you do this by default, if you have an implement the interface method for you, it's probably going to say O1 and O2. So in this example here, I want to actually sort them instead of in ascending order, descending order. So I want this to return a positive value if the first object, the student1 object, is shorter than the student2 object. So I can just sort of reverse the subtractions here. So I can say student2 get height minus student1. So if student2 is taller, it's going to return a positive value, which then means the student1 needs to occur after, or in this case, is a greater object. And so I can use that to actually sort of change whether I'm going to sort in ascending or descending order. If I actually want to use this and compare based on the new height comparator, what I can do when I call collections.sort, I still pass in my collection of students that I have, but I can pass in a second parameter here. The sort method is actually overloaded. So I can then say, use my new height comparator. And then when I call this, it's actually going to sort using my height comparator. If I just call collections.sort, CS63 12 students, this is going to just use whatever criteria I implemented in the comparable interface. In this instance, it's going to sort in ascending order based on grade. Now, the last thing I want to talk about is comparing strings. When we compare strings, if we want to use them in a comparator or the comparable interface, the strings have actually implemented the compare to method. So that returns -1, 0, or 1 based on the comparison. So in this example here, I've got jungle and alphabet. So if I say string1 compared to string2, because jungle occurs after, this is going to return a 1 saying that string 1 is actually greater and needs to occur after string 2. Now we can then use that to help us when we're writing our comparable or comparator interface methods. So let's say I just want to compare based on the last name. So I've got public class last name comparator implements the comparator as a templatized type. I've come in here. Now I'm going to compare on their last name, so I get my last names. And then I can come in here and just, instead of doing an equals or trying to determine on my own, I can leverage the strings compare to method and just say return name1 dot compare to name2. So that's then going to sort my collection when I call this in ascending order. The last thing is where some real power can come in, is I can use these comparators to implement a multi-level sort. So let's say that we want to sort by last name, and then if the last name is equal, we want to sort by the first name as often is done in a phone book. To do that, we need to do a little bit more logic when we implement our comparator. So I've come in here, I've named this one last then first name comparator, because that a name that's indicative of what we're going to be doing. So we're going to sort by last name. If that's equal, then we're going to sort by first names. So I have my signature here. I come in and I get my first and last name. Now what I do here, the first thing I want to do is I want to see if the last names are equal. So I say if name1 dot equals name2. If they are equal, then what I want to do is get the first name and compare based on first name. And then I can go ahead and leverage and call the compare to method, and that's going to sort by first name on these two particular objects. Otherwise, if the last names are not equal, I just want to then sort by my two last names using that compare to method. So I can then implement a two-level sort, which will first sort by last name. Then if the last name is equal, it's going to roll over and sort by the first name. I know that was a lot, and this concept of implementing interfaces, in particular the comparable and the comparator interface, can be a little bit confusing, but you will get some additional practice with this in your homework assignment.